Perplexity just dropped something that nobody in the AI search world expected. And honestly, the developer community is still figuring out what this means for everyone building AI apps. We are talking about pplx-embed, a brand new family of AI models that can search through over 1 billion web pages. Builds Google's own embedding model on key text, shrinks your storage cost by up to 32 times, and is available completely free under the MIT license. Alright, so first, what is an embedding model and why does it matter? Well, think of it like this. When you type a search query, an embedding model is the thing that converts your words into a list of numbers, a kind of fingerprint for the meaning of your text. Then it compares that fingerprint against millions or billions of stored document fingerprints and finds the closest matches. This is the engine behind AI search, behind tools that answer questions by pulling in real documents, and behind basically every serious AI assistant that needs to look stuff up. The problem is, until now, most of the best embedding models were either expensive to run, locked behind paid APIs, or built for clean academic data rather than the messy, noisy text you find on the real web. Perplexity just changed that conversation completely. Here is the thing. Perplexity is not just an AI company trying to look cool. Their entire product, the AI search engine millions of people use every day, runs on retrieval. When you ask Perplexity a question, it has to search through billions of web pages in real time and bring back the right documents within seconds. So, when they build embedding models, they are building them to survive the real world, not just score well on academic tests. And that experience is back into everything about pplx-embed. Now, let's get into the numbers, because this is where things get really interesting. On MTEB Multilingual version 2, which is one of the most important retrieval benchmarks in the field right now, the pplx-embed 4 billion parameter model with int8 compression scored 69.66% on NDCG at 10. For context, Google's Gemini Embedding 001 scored 67.71% on that same test. Queen 3 Embedding at the same 4 billion parameter size scored 69.60%. So Perplexity came in at the top of the chart, matching or beating models from Google and Alibaba. And it does this while using far less storage than those competitors, which we will get to in a second. But here is where it gets even more interesting. And this is the number that honestly shocked me. On contextual retrieval, which is when you need to find the right chunk of a document, and that chunk's meaning depends on the full document around it, pplx-embed context v1 at 4 billion parameters scored 81.96%, average NDCG at 10 on the Cohere benchmark. Voyage context 3, which is the next best model, scored 79.45%. Anthropic's contextual retrieval system scored 72.4%. That is almost a 10-point gap over Anthropic and more than 2 points over the previous leader. For a benchmark this competitive, that kind of jump is enormous. And the real-world tests are even more impressive than the academic ones. Perplexity built two internal benchmarks called pplx query to query and pplx query to doc. These are not clean academic datasets. pplx query to doc tests retrieval against a corpus of 30 million real web pages, pulled from over 1 billion web pages in total, using 115,000 actual search queries from real users. On pplx query to query, with a 2.4 million document pool, the 4 billion parameter model hit 73.5% recall at 10, beating Queen 3 Embedding's 67.9% by 5.6 percentage points. The smaller 0.6 billion model hit 71.1%, which still crosses BEGN3 at 61.8%, and Queen 3 Embedding at its same 0.6 billion size, which only managed 55.1%. On the 30 million document search test, pplx-embed's 4 billion model hit 91.7% recall at 1000 compared to 88.6% for Queen 3. In search pipelines, these 3 extra points of recall can be the difference between finding the right answer and missing it completely. Now, let's talk about how they actually built this. because the technical choices are genuinely smart. The first big decision was the backbone architecture. Perplexity started from queen tree-based models, which are normally casual decoder models, meaning they read text left to right and each word can only see the words that came before it. That design is great for generating text, but it is actually a problem for understanding text. When you are trying to understand what a sentence means, you want to see the whole sentence at once, right? Not just what came before each word. So, Perplexity used something called diffusion based continued pre training to convert those casual models into what are called bidirectional encoders. The model gets trained to reconstruct randomly hidden words using the full context around them, not just the words to the left. They did this on approximately 250 billion tokens of text across 30 languages, and in their test, this one change alone gave roughly a 1 percentage point improvement on retrieval tasks compared to just using the casual version. The second key piece is how they handled the size problem. At web scale, storing number list in full precision is virtually expensive. If you are indexing 10 billion pages, even a small saving per embedding adds up to terabytes of storage. Most companies deal with this by training their model normally and then compressing the numbers afterward, which always hurts performance. Perplexity did it differently. They baked comparison directly into the training process from the very beginning, using something called quantization aware training. The models produce int8 embeddings natively, which shrinks storage by 4 times compared to full precision, with zero performance loss. They also support binary embeddings, shrinking storage by 32 times, which only about 1.5 percentage points of performance drop at the 4 billion scale. That is an enormous engineering win. You can literally store 32 times more documents in the same amount of memory. The third piece is what they call Matryoshka Representation Learning, or MRL. Think of it like a Russian nestling doll. The embedding is structured so that you can cut it short and it still works. Developers can use a shorter version of the embedding vector to save even more storage and speed up search without training a completely separate smaller model. This gives teams a lot of flexibility to tune the cost performance trade off for their specific use case. And then there is the contextual embedding model, which is a separate variant built specifically for something called RAG, or Retrieval Augmented Generation. In RAG, you have a big document and you break it into smaller chunks to store and search. The problem is that when a chunk is taken out of context, it can lose its meaning. A sentence that says, "he decided to invest everything," means something totally different depending on what came before it. Perplexity's context variant trains each chunk's fingerprint to include information from the whole document it belongs to. So even isolated chunks still carry context. That is why it beats every other contextual model on Cohere by such a large margin. Now, a few things worth pointing out that are not perfect. The binary quantization works much better at the 4 billion scale than the 0.6 billion scale. At the smaller model size, going binary costs you 2 to 4 percentage points of performance compared to just 1.6 at a larger scale. So if you want the extreme 32x storage savings, you really want the bigger model. Also, these are embedding only models. They do not generate text on their own. They are search tools, not chat tools. And while Perplexity's internal benchmarks are more realistic than academic tests, they are still internal benchmarks. Independent teams will need to verify those results in their own pipelines over the coming weeks. The bigger picture here is that Perplexity is quietly becoming a serious player in the AI infrastructure space, not just in the consumer search space. They're already running one of the highest scale retrieval systems in the world just to power their own product. And now they're open sourcing the models that make that system work. This puts pressure on every company selling embedding APIs, including Cohere, Voyage, OpenAI, and Google. When a model that beats Google's embedding API is free under MIT and available on Hugging Face right now, that changes the pricing conversation for everyone. The team that wins the AI search race over the next few years is going to be the one that gets retrieval right. Not just the chat interface on top, but the part underneath that finds the right information from billions of documents fast and accurately. Perplexity just published a blueprint for how to do that, and every team building RAG pipelines, AI agents, or enterprise search tools now has a new baseline to work from. That is where we will wrap it up. The real question now is whether Perplexity keeps these models updated as their production system evolves, or whether this is a one-time release. Because if they keep pushing improvements from their live search pipeline back into open source, this could be a recurring advantage for the entire developer community. Drop your thoughts below. Make sure you are subscribed, hit the like button, and I will see you in the next one.